Your body is smarter than you are. Right now, as you sit here, it's performing roughly 37 trillion cellular operations per second, breathing, filtering, repairing, remembering, all calibrated to one very specific environment. Oxygen at 21%, atmospheric pressure at 101 kilopascals, temperature between -10 and 40 degrees Celsius, gravitational pull at 9.8 meters per second squared. Your body doesn't know how to exist outside these parameters because it's never had to learn. Evolution gave you exquisite adaptation to Earth and nothing else. Mercury's gravity is only 38% of ours. Its daytime temperature reaches 430 degrees Celsius, hot enough to melt lead. Your body would begin making desperate, catastrophic adjustments the moment you arrived. And here's what breaks my heart. Those adjustments would work just well enough to keep you alive while destroying any chance you'd ever be human again. Your body would save you by transforming you into something that cannot come home. I imagine you've clicked on this video for a reason. Perhaps you're curious about the limits of human exploration. Perhaps you've wondered whether we could actually send people to Mercury, the closest planet to our Sunday. Perhaps you believe that with enough ingenuity, enough technology, enough determination, humans can go anywhere in our solar system. But I want to offer you something different today. Not inspiration through impossible dreams, but clarity through understanding limits. Because knowing what we cannot do makes what we can do infinitely more meaningful. You've been sold a magnificent lie your entire life. That human exploration is unlimited. That anywhere in our solar system is merely difficult rather than fatal. That with enough technology, we can overcome biology itself. The truth is far more humbling and far more beautiful. The barrier to Mercury isn't technological. We could build a spacecraft capable of reaching Mercury. We've already done it with robotic probes. The barrier is your body, your skeleton, your DNA, your cardiovascular system, your mind. Mercury isn't a destination that refuses to welcome us. It's a transformation chamber that operates on a one-way mechanism. You can go there, but you cannot come back as yourself. What I'm addressing today isn't really about space exploration. It's about the modern delusion that we can optimize ourselves into anything, that our bodies are obstacles to overcome rather than specifications to honor. You'll gain something rare by the end of this. Permission to stop believing you must transcend your own nature to matter. You'll understand what biological limitation actually means, not metaphorical limitation, not "you're not trying hard enough" limitation, but the hard physics of what happens when you place a terrestrial organism in an environment so hostile that survival itself becomes a form of destruction. Let me start by telling you about a spacecraft called Messenger. In 2004, NASA launched this probe toward Mercury. It took 7 years to arrive, even though Mercury is, on average, the closest planet to Earth. 7 years. Why so long for our nearest planetary neighbor? Because getting to Mercury isn't about distance alone. It's about fighting the sun's gravitational pull every step of the way. Messenger had to perform 6 planetary flybys, 1 past Earth, 2 past Venus, and 3 past Mercury itself, just to slow down enough to enter orbit without falling into the Sunday. The spacecraft spent 4 years circling Mercury, studying its surface, its magnetic field, its composition. And during those 4 years, something fascinating and terrible happened. The probe's instruments began to degrade, not from mechanical failure, but from radiation damage. Mercury sits so close to the sun that solar radiation is 11 times more intense than what we experience on Earth. The spacecraft's cameras started producing images with increasing artifacts as high-energy particles bombarded the sensors, corrupting the electronics. In 2015, Messenger's fuel finally ran out. The spacecraft crashed into Mercury's surface at 3.91 kilometers per second, creating a crater 16 meters wide. There was no ceremony, no memorial, just physics. The probe had become part of the planet it studied, consumed by the environment it measured. And here's what haunts me about that mission. Messenger was designed for this. It had radiation-hardened electronics, thermal shielding, no biological components to protect. And still, Mercury slowly poisoned it. Still, the environment proved too harsh for the mission to continue indefinitely. Now imagine that spacecraft carried humans instead of instruments. Imagine awareness experiencing that degradation, vision corrupting, memory failing, body transforming, and no ability to leave because the trajectory is locked, the fuel is limited, the return window is closing. Let me tell you about a study that NASA conducted but never publicized. In 2018, they modeled a hypothetical human mission to Mercury. 5 years traveling there, 5 years in orbit conducting research, 5 years returning to Earth. They input every known biological variable. Radiation exposure rates from being so close to the Sunday bone density loss from reduced gravity, muscle atrophy, cardiovascular changes, neurological degradation. Then they ran the simulation forward through 15 years. The computer model predicted something unexpected. Not a dead astronaut, a living one. But the parameters of that life were transformed beyond recognition. After 15 years, the model showed bone density at roughly 40% of baseline, similar to severe osteoporosis in elderly patients. The heart would have remodeled itself for low gravity and microgravity environments, fundamentally incapable of pumping blood effectively against Earth's gravity. The astronauts' telomeres, the protective caps on DNA that prevent degradation, would resemble those of someone 80 years older. Spatial reasoning would be impaired. The immune system would fail to recognize Earth-based pathogens after 15 years away. But here's the detail that stopped the researchers cold. The model predicted that the astronauts' subjective experience would normalize, that after years of deterioration, the body's degraded state would feel normal. The weakness would feel like baseline. The confusion would feel like clarity. You'd arrive back at Earth feeling fine, believing yourself recovered, and then gravity would kill you. The report's conclusion was stark. Return is technically possible. Survival upon return is not. So let me take you through what Mercury actually is, and why it represents an absolute boundary for human biology. Mercury orbits the Sun at an average distance of 57.9 million kilometers. That's close, incredibly close. For comparison, Earth orbits at about 150 million kilometers. But here's what that proximity means in practical terms. The Sun doesn't just emit light. It emits a constant stream of charged particles called the solar wind. It releases X-rays, ultraviolet radiation, and during solar flares, massive bursts of high-energy particles. On Earth, we're protected by two things: our atmosphere and our magnetic field. The magnetic field deflects most charged particles. The atmosphere absorbs the radiation that gets through. Together, they block about 99.9% of the Sun's harmful output. Mercury has neither advantage. It has a magnetic field, but it's approximately 1% as strong as Earth's. The field exists, but it's too weak to provide meaningful protection. And Mercury has essentially no atmosphere, just an exosphere, a thin shell of atoms kicked up from the surface by solar wind impacts. There's nothing to absorb radiation, nothing to slow particles. You would be exposed directly and constantly to the full fury of a star at close range. Earth receives about 1,361 watts of solar energy per square meter. We call this the solar constant. On Mercury, that number increases to roughly 9,000 watts per square meter. That's 6.6 times more intense. But intensity is only part of the equation. The composition of that radiation is what kills you. High-energy particles don't just heat your body. They pass through matter, tearing through molecules, shattering chemical bonds, breaking DNA strands. When radiation hits your cells, it causes what's called ionization. It rips electrons away from atoms, creating charged particles inside your body that react violently with surrounding tissue. Your DNA breaks. Sometimes your cellular repair mechanisms fix the break correctly. Sometimes they fix it incorrectly, creating a mutation. Sometimes the damage is too severe, and the cell dies or becomes cancerous. On Earth, we receive enough background radiation that our bodies evolved robust DNA repair systems. But these systems have limits. They can handle a certain rate of damage, exceed that rate, and damage accumulates faster than repairs can happen. On Mercury, you would exceed that threshold immediately and continuously. NASA's current career radiation limit for astronauts is 1 sievert, which corresponds to about a 3% increase in lifetime fatal cancer risk. A mission to Mars would approach that limit. A mission to Mercury would exceed it within the first year. But the damage isn't just about cancer risk decades later. Radiation accelerates aging at the cellular level. It damages cardiovascular tissue, increasing heart disease and stroke risk. It affects the brain directly, causing cognitive decline, memory problems, difficulty making decisions. And here's the cruelest aspect. This damage is cumulative and largely irreversible. Every particle that tears through your cells adds to the total. You can't undo it. You can't heal it. Even if you left Mercury after 1 year and returned to Earth, the damage already accumulated would follow you for the rest of your life. But let's say you somehow solve the radiation problem. You still face Mercury's temperature extremes. Mercury's rotation is strange. The planet takes 59 Earth days to complete one rotation on its axis, but only 88 Earth days to complete one orbit around the Sunday. This creates a situation where one Mercury solar day from noon to noon lasts 176 Earth days. Think about that. Sunrise occurs, and then you wait 3 months for the sun to climb to its highest point. Another 3 months for it to set. During those 3 months of continuous daylight, surface temperatures reach 430 degrees Celsius. That's hot enough to melt lead, zinc, and tin. Then night comes. With no atmosphere to retain heat, temperatures plunge over the following 3 months to minus 180 degrees Celsius. That's colder than the coldest temperature ever recorded on Earth by more than 90 degrees. The temperature differential between day and night on Mercury is 600 degrees Celsius. No material we've ever created can handle that kind of thermal cycling indefinitely without degrading. You might think, we'll just stay in orbit. We won't land on the surface. But orbit doesn't protect you from the radiation. You're still exposed to the solar wind, still bathed in high-energy particles, still accumulating cellular damage every moment. And orbit introduces a different problem: microgravity. The International Space Station orbits at about 400 kilometers above Earth. Astronauts there experience microgravity. They lose 1 to 2% of their bone mass per month. Their muscles atrophy. Their hearts shrink because they don't have to work as hard to pump blood without gravity. After 6 months on the ISS, astronauts return to Earth needing weeks or months of rehabilitation just to walk normally again. A mission to Mercury would require years in space. 5 years traveling there, 5 years in orbit, 5 years back. That's 15 years of reduced or zero gravity. After 5 years, your bones would resemble those of someone with severe osteoporosis. After 10 years, they'd be so porous, so fragile, that a minor impact could cause fractures. After 15 years, your skeleton would be more void than calcium. Attempting to walk on Earth after that duration wouldn't just be difficult. Your legs would shatter under your own weight. Your heart suffers the same fate. On Earth, your heart must work against gravity to pump blood upward to your brain. In microgravity, that challenge disappears. The heart adapts by shrinking. Blood volume also decreases. When astronauts return to Earth after just 6 months, many experience orthostatic intolerance. They faint when they try to stand because their hearts can't push blood to the brain fast enough against gravity. After 15 years, your cardiovascular system would be so thoroughly adapted to weightlessness that re-entering Earth's gravity would cause cardiovascular collapse. And then there's the psychological dimension. Research in extreme environments shows a consistent pattern of psychological deterioration during extended confinement. The first few weeks are exciting. Novelty sustains you. Then routine sets in. But after about 6 months, psychological strain becomes measurable. Sleep disruption, interpersonal conflict, emotional blunting. Beyond 12 months, cognitive changes appear. Memory problems, difficulty concentrating, depression that doesn't respond to normal interventions. And all of that research involves people who know they can leave. A Mercury mission offers no such comfort. At Mercury's distance from Earth, which varies from 77 million to 222 million kilometers, depending on orbital positions, a radio signal takes between 4 and 12 minutes to travel one way. A conversation with mission control isn't a conversation. It's an exchange of recordings separated by vast silence. If you have a psychological crisis, Help is delayed by, at minimum, 8 minutes round trip. If you have a medical emergency, there is no evacuation. You are alone in the most absolute sense that word has ever meant. So, you arrive at Mercury. And what's there? The surface is covered in regolith fine gray dust, created by billions of years of meteorite impacts. There's no water, no ice, no resources that could sustain human life. Every moment on or near Mercury is another moment of radiation exposure, another day of bone loss, another increment of irreversible change. We've already studied Mercury with robotic probes. Messenger orbited for 4 years, and sent back data scientists are still analyzing. Bepi Colombo is currently en route. These probes can withstand conditions no human could survive. They don't need life support. They don't need to return. The question isn't whether we can send humans to Mercury. With enough resources, we probably could. The question is, what would return? Not the people who left. Someone else. Something else. A human-shaped collection of fragile bones, weakened heart, radiation-scarred cells, and psychologically transformed mind. And they wouldn't be able to step off the spacecraft. They'd be carried off because their legs couldn't support them. So what do we do with this knowledge? Each day, try to identify one thing that is genuinely impossible. Not difficult, not unlikely, but actually impossible, given the laws of physics and biology. Sit with that impossibility. Notice what happens when you stop fighting that truth. Often, there's relief. Choose something you love that you cannot touch. Instead of grieving the distance, ask, what does this distance protect? Mercury's distance protects it from human interference. It also protects humans from Mercury. Distance isn't always loss. Sometimes, it's exactly the right amount of space for both things to remain beautiful. Honor your specifications. Your body isn't broken because it can't survive Mercury. It's precisely calibrated for Earth. Your lungs breathe air at the exact pressure Earth provides. Your eyes see in wavelengths that match our filtered sunlight. Your bones are strong enough to hold you upright in exactly this gravity. You are not a failed prototype of a universal being. You are a successful implementation of a terrestrial one. You are not diminished by your limits. You are defined by them. The fact that you cannot survive Mercury doesn't make you weak. It makes you human. It makes you exquisitely adapted for liquid water and breathable air, for gravity that keeps your bones strong, for a magnetic field that shields your cells, for a star at precisely the right distance. Your body is not an obstacle to transcend. It's a love letter from 4 billion years of evolution, written specifically for this planet. Every breath you take, every heartbeat, every moment of consciousness is calibrated to Earth with such precision that removing you from this environment doesn't free you. It erases you. Mercury will continue its strange, scorched orbit long after our species is gone. Its value doesn't require human presence to validate it. Perhaps that's the deepest lesson. Some things are meant to be witnessed from afar, appreciated without possession, loved through the discipline of distance. You belong here, right here, on this improbable blue sphere spinning through the void. You belong to the weight that keeps you grounded, to the atmosphere that lets you breathe, to the magnetic field you cannot see, but which shields you every moment. Your bones know this. Your blood knows this. Your DNA knows this. If this perspective has shifted something in you, I'd be grateful to hear about it in the comments. Tell me, what's one impossible thing you're learning to appreciate from a distance? And if this has given you a new way of holding both wonder and realism in the same breath, I'd be honored if you'd subscribe. Look up at the night sky if you can. Find Mercury, that tiny point of light closest to the sun, visible only at dawn or dusk. Feel the ground solid beneath you. Feel the air moving through your lungs, and know that you are already home.